Welcome back to the Scotti-BYTE channel, and this is Scott. So today we want to talk about network booting. And specifically, we want to talk about using a tool named iVentoy to do network booting. And we're going to do that by hosting iVentoy inside of an Incus container. So Ventoy is an application I've used for a couple of years now to boot any ISO from a USB menu. Basically, you can have a USB stick with a whole bunch of bootable ISOs on it, and the Ventoy application presents you with the menu and allows you to boot any of them. And then I have a tutorial that is entitled LXD VM with Netboot.XYZ, and if you haven't seen it, you should give it a watch. And I showed how to boot a LXD VM via a Network PXE boot. And so iVentoy is also a Network PXE boot utility, and it's been around since July of 2023, and it can be a little challenging to initially configure, and I'm going to demystify that here. So iVentoy works like Netboot.XYZ, except that you can boot virtually any bootable ISO by simply placing it inside of an ISO folder. And although I show iVentoy booting in an Incus VM and in VirtualBox, really the real use case for PXE network booting is on bare metal machines on your network, and it can be used to either boot a machine that is not booting to help diagnose what might be wrong with it, or installing an operating system from bare metal without having to have installation media with you. So in this tutorial, we are going to learn some tricks to host iVentoy in an Incus container. Let's begin with a little bit of a demonstration showing what iVentoy can do, and the way I'm going to present this demonstration is by starting a Incus VM called NetClient, and this particular Incus VM boots from the network. So as we execute this, it goes ahead and brings up the remote viewer. When the remote viewer comes up, it goes ahead and boots PXE over the network. What it's doing is it is finding the Incus container for iVentoy, and here it is presented the menu from the iVentoy application. So here I have 4 ISOs that are stored in the directory for this particular boot process, and one is for Windows 11 23H2, another is for RescueZilla, and another is for Ubuntu. So just as an example, I can go ahead and start this Ubuntu desktop instance. I hit enter and it says try or install Ubuntu. And then I hit enter again and it goes out to the network and does a network boot. Now you notice here on the screen for just a moment the graphics corrupted, and that's just because it didn't have access to a spice driver immediately, and for the remote viewer it requires a spice driver for Incus and LXD also for that matter. So it's going ahead and booting up, and here we go into the what looks like the desktop, but actually you have that main screen where it says try Ubuntu or install Ubuntu. I'm just going to go ahead and click try Ubuntu, and of course it's going to continue the boot process, and when it finishes that boot process it will give us a live version of Ubuntu desktop for us to go ahead and try out. And here you can see that it is working perfectly. Here I'm rebooting my Incus VM to go ahead and execute, and I guess I had already stopped it, so in this case I'm going to go ahead and say Incus start NetClient, and again I'm booting up here, and it will perform a PXE boot. As soon as it gets done with the PXE boot, we should see the menu for iVentoy, and there it is. So I'm going to launch RescueZilla this time, And of course it comes up and it lets me start RescueZilla. When I hit enter, it's going to go off and perform the rest of the boot. As you can see, it's kind of corrupted at the top of the screen. Again, that's sort of a SPICE driver issue. And as soon as it gets around that, it will go ahead and boot up. And as you can see, there was the desktop for RescueZilla. So basically, you can take any images you want and put them in this folder over an iVentoy, and it will perform a PXE boot for you. And this is really convenient. Generally, if you're out on your network and you want to run a particular operating system instance or do an install or just use it to check something out. I wanted to demonstrate iVentoy booting a Windows CD. Unfortunately, I could not do that from my Incus VM, and the reason for that is because the Incus VM requires SPICE drivers in order to execute the display when you go into graphics mode. So those are not built into the Windows ISO. Rather than repack the Windows ISO, I just built myself kind of a throwdown VirtualBox VM here, and I'm going to go ahead and start it. So when that VirtualBox VM starts here, it will also perform the PXE boot, and it will go out to the network, and it brings up the iVentoy menu just the same way. Except this time I'll go ahead and I'll launch that Windows 11 23H2 CD, and it will go ahead and start up the Windows setup. So this is useful, of course, if you're out on your home network and you don't have any media, but you want to install Windows from there, or maybe even go into a Windows Rescue disk. You could have your Windows Rescue disk on iVentoy and it would work. And after about a handful of seconds, we come up to the Windows setup screen. Of course, here we can go next and we could click on Install Now. I'm not going to do that in this particular case. Here's the web page interface for iVentoy, and you notice it says up here iVentoy free. They actually do have a licensed version of this that's like $49. It is open source software. The paid version, if you will, the licensed version is what they refer to it as, just provides a little bit more support. One of the things I believe it provides is the ability to boot images from an ARM processor. Other than that, there's a limitation of 20 different systems that you can have, which works great for a home lab. Of course, the registered paid version has no limit on it. Anyway, this is the main screen, and it's a boot information screen. It basically says that the server is up and running. You can stop it, and then you can turn around and start it again. And when it starts, it's a new instance, so that's all there is to it. And then up here, it just gives the address of your iVentoy boot server, which of course is the same address you get here too in the web interface, which is that address and port 26,000. In this case, the nickname is going to be ETH0 because our iVentoy is going to be running inside of an Incus container. Not an Incus VM, but an Incus container. And then under configuration, we have a number of things, and I'm going to go over this later, but I just wanted you to see the interface now. You also have the ability to do MAC filtering, deciding who can boot from this thing on your network, and in image management. This is kind of the important part. You can drop files, ISO files, into a particular folder in the iVentoy installation. And once you do so, then those are the images that appear on the iVentoy menu. And then finally, you have the registrar information, which is just saying that you're running the free edition, and you can subscribe to the professional edition. So if I click on the professional edition, it simply says the free edition is not for commercial use, provides up to 20 clients, does not provide ARM64 support, and it's free. The Pro Edition is permissible for commercial use. It has no limit on the maximum number of clients. It does support ARM64 systems, and it costs $49. So, I mean, a great deal, a wonderful product. And let's go out and see how to install iVentoy. Those of you who subscribe to the channel and have gotten to know me know that when I present a particular software, I do so because it usually has some kind of unique requirements that allows you to learn more about the infrastructure. And creating a container for iVentoy is exactly that. So in this particular case, we are performing an Incus launch of Ubuntu 2204. So it's just a regular container, not an Incus VM. And I'm calling this thing iVentoy. And here in the past, I've always put -- profile, but you can abbreviate that -p and say -p default, which means we use the default profile. And the default profile is a requirement in order to be able to start containers. It's just that if you don't specify it, normally it will use it anyway. The exception to that is if you want to have additional profiles, then you must specify it. So in this particular case, I'm also specifying the bridge profile. If you don't know what the bridge profile is, you need to go over and watch my video entitled Incus Containers Step by Step, which explains how to set up the bridge device and the bridge profile. And basically all we're doing with this is bridging this out to the main LAN so that this container has an address on the main LAN, which we'll need for the Incus, or not Incus, for the web clients to be able to boot from this. So then we have security.privileged equal to true. That means that it has certain privilege on the Incus host or the Incus server on which the container is running. And then we have a brand new one here, raw.lexc, and that's equal to lexc.apparmor.profile equals unconfined. What the heck is going on there? So basically what that does is it allows access to the Incus host that would normally be blocked by the stock security profile, which protects the container from external threats. And in this particular case, we know which app we're running, so this is not an issue. And finally, the last thing we have here is boot.autostart equals to true. And what that does is every time that the Incus server boots, it will start this iVentoy container automatically. Now, another question that you might have is, well, gee, how come we have all these things that say raw.lexc and lexc.apparmor? I thought we were running Incus. And that's true, we are, but realize that both for a LXD server and an Incus server, the underlying technology is Linux containers, and that is LXC by default. So what Incus or LXD adds to Linux containers is it adds an API and it also adds a CLI. Now that our container is launched and started, let's go ahead and connect into it with an Incus shell iVentoy. Once we get in there, we want to do an apt update, ampersand apt upgrade -y, just to make sure that all of the updates and upgrades have been performed to this container and that it has everything installed in it to the latest version. And as you can see here, it's having to grab just a few updates. Now that we have all of the updates installed, one of the first things that I like to do is add myself a user account. When you create an Incus container, the root account that we're signed into right now exists, but we don't generally use it for operations. And there is an Ubuntu account that gets created, but it's not originally created with a password. So we're going to go ahead and do an add user, in my case Scott. I'll go ahead and give Scott a password. And then I'm going to go ahead and grant Scott sudo privilege by doing an usermod -a capital G sudo Scott. Let's go ahead and install the dependencies for iVentoy, and those are going to be wget, and I like to put in OpenSSH server, and that's for some management that we're going to see later. I like to install net-tools and also the nano editor. So we go ahead and install those dependencies. With the dependencies installed, let's go ahead and SU over to the Scott account. And then let's go ahead and download the version of iVentoy. And as of April 19th, 2024, when this video is being made, that current version is 1.0.20. And so I do a wget and it goes ahead and downloads that file. If we do an ls, there you can see the tar.gz file for iVentoy. Let's do a make dir on iVentoy, and then let's do a tar extract of the iVentoy file, and I'm using this --strip2 to strip the top level directory and go ahead and put everything into the iVentoy folder. So now if I cd into iVentoy and I do an ls, there are all the contents of the iVentoy tar, which we've now extracted. At this point, we can actually run the program simply by doing a sudo /iventoy.sh -A start, and we provide our sudo password, and it says success. Now you know this worked if it does not say that the PID was 0, but instead the PID is a positive number. In order to see if your iVentoy is working, I can always do an ifconfig, and here you can see that the address is 172.16.1.248, and as it says up here, you want to visit that address with port 26,000. So now if I do that in my web browser, go to 172.16.1.248:26,000, in my case, you'll see that it brings up the iVentoy interface. For right now, I'm not going to continue with the configuration of iVentoy. Instead, I'm going to go ahead and exit this and come back to the prompt. So the one problem with this command is the fact that every time you reboot your Incus container, you're going to need to come in here and execute that particular command. So a way around that is I designed a service that will solve that problem. So in order to install that service, we're going to do a sudo nano /etc/systemd/system/iventoy.service. So now we're going to build a service, and that service is going to go ahead and make sure that iVentoy starts anytime the iVentoy container comes up. And so this is what that service looks like. So first of all, the service is, the description is simply iVentoy, and it says it's going to start after the network-online target, which basically means your network comes up. But what I found out is your network coming up and your network actually providing an IP address to your instance takes just a little bit longer. So then I have a type equals forking on the service, and then I have this a couple of environment variables for iVentoy, which is iVentoy API all equals 1 and iVentoy auto run equals 1. And then you have here a library path that points down to this particular folder, this Lin64 folder that is inside of the iVentoy. And then all this will be in the show notes, of course. And then you have the LD library down there as well. And so then we have an exec start on iVentoy. So the trick, other than the fact that we had to start after network-online target was true, I also went out and created an exec start pre where I say /bin/sleep 40, which basically means that this particular service, when it's starting up, it waits for the network to be online, but then it waits another 40 seconds, and after that point, then life is good. And it goes ahead and starts correctly in my multiple tests. So I went ahead and saved that file out with a Control-O and Enter and a Control-X to exit the Nano editor. And at this point in time, we want to go ahead and do a sudo system reload or daemon reload, and that'll go ahead and parse the service directories and note any new changes. Then we're going to do a sudo system CTL enable iVentoy service, which goes ahead and makes sure that that service is started on next reboot, and it creates a symlink in the service directory to be sure that happens. And then if I want to start that service now, I can go ahead and say systemctl start iVentoy.service. And of course, that's going to take 40 seconds to start because of that 40-second sleep period that I talked about earlier. Due to the miracle of video, 40 seconds has now passed. And if you wanted to see whether your iVentoy service was up and running, you could always do a netstat-plant, and netstat was installed as a part of net-tools. When netstat-plant comes up, if you see an entry for port 26000, that's an indication that that listener is up and running and the iVentoy instance is running correctly. There's really nothing much to installing iVentoy, and when you go to the boot information screen, you'll see that it has automatically detected the IP address. In my case, my subnet mask is 255.255.0.0, which it's also automatically detected. Yours will probably be 255.255.255.0. And then it will go ahead and specify the beginning and end of an IP pool that it's going to use. But we're not going to do that because we're instead going to use your main DHCP server pool. And the way we're going to do that is by going off to the configuration menu. But before we go there, I want you to notice that a brand new installation of iVentoy, you're unable to start. If you click the start button, it'll just come back and say that it has no ISO files detected because we haven't put any ISO files into the ISO directory. With that in mind, let's go ahead and head over to the configuration screen. And I'm going to have you change the DHCP server mode from internal to external. And once you change that to external, I'm not sure whether this save up here applies to that or not. I think it only applies to these things up here, but I've discovered as soon as I change this to external, it is set at external. If I go back up to configuration then, or actually up to boot information again, we don't have that information out here that we did before. This time it just says, hey, here's our server address, and we're just using ETH0, but we don't have anything about the subnet mask and all of that. So that's really all there is to configuring this side. To make iVentoy actually work, you have to configure PXE booting on your router. And unfortunately, this is different for every router. In my particular case, I have a Ubiquiti Unify UDM Pro, and I've gone up here and I've edited the networks section, and I'm editing my main network because that's where I want to do PXE booting. And then I go ahead and I scroll down on the screen, and I have an option for DHCP management to show more options. So if you're looking at your router, you should have an option that is roughly called network boot. Right here is where you want to put in the address of your Incus container for iVentoy that we just created. Not your Incus server, but the Incus container for iVentoy we just created. That's the same address as we put in the web browser. And then over here, we want to put iVentoy underbar loader underbar 16,000. And this is a special file that looks at the various types of boots, meaning a master boot record boot versus a UEFI boot, and it decides which files to pass off to it from the ISO in order to get that to boot correctly. So once you have all of these set, however you do that in your router, you want to go ahead and click the save option, and then from that perspective, your router now knows that it's supposed to network boot clients on your network that ask to be network booted, and they do so by going to the address of the iVentoy container, and they look for this particular loader file. So where do we put the ISO files in particular? Well, if you do an ls here on the iVentoy folder, you will see that there is a folder called ISO. And inside this ISO file, if we cd into ISO, in this ISO file or ISO folder, that is where you want to put your ISO images. Since we installed OpenSSH server on our iVentoy container, not only does it allow to SSH into the server, but it supports the SFTP SSHFS file system so that we can move files over to it easily from the GUI. In this particular case, you'll notice that I have a folder called iVentoy ISO files, and that is pointing inside the container. I can show you what that link looks like. It's basically SFTP://iVentoy, only because I have a DNS. You would maybe want to put your IP address of your container in there. And then I have /home/Scott/iVentoy/ISO. And here are the 4 ISO files that I have put over there. Basically, I download them on my local machine and I drag and drop them into this folder. As an example of this, here I've accessed SFTP on 172.16.1.248. And now that I'm over there, after providing my username and my password, all I have to do is go over to Home and Scott and iVentoy and ISOs. And so I can go grab an ISO file from someplace on my local hard drive. Here I am copying the Ubuntu 22.04 live server ISO from my local system over to the ISO folder of iVentoy container. And once this gets copied over, you'll be able to come back and see how it looks. Now that the transfer is completed, you can see that the ISO file is in that folder. And once that occurs, the next thing we can do is to go back up here and go to Image Management. In Image Management, I can do a refresh, and it finds the folder or the file that is in that folder. And so now we can go back up to boot information and we can turn on the server. And this time, instead of telling us there's no ISO files there, it correctly starts and is serving out that file to anyone that does a PXE boot. At this point, once you have the iVentoy Incus container up and running and you have it started, it will remember to start every time in virtue of both the fact that we have boot.autostart equals to true when the Incus server boots, and also because we have the service inside of that Incus container set to start up iVentoy automatically, and it will remember that it was running here. And if you want to add any more images to it, all you have to do is go over to that folder, drop them in here, and click on refresh, and they will appear in the iVentoy boot menu anytime someone is booting PXE on your network. In addition to that, don't forget that you have to go out and make those settings on your router in order to tell it about the boot file and the address of the iVentoy container. So in summary, the Incus container for iVentoy required security.privileged to be equal to true and the raw.lexc setting to be set to lexc.apparmor.profile equals unconfined. These settings provide the Incus container with the required access to the Incus server to allow iVentoy to execute properly. And we also learned how to allow iVentoy to start as a service properly when the iVentoy container is started. And we created an Incus VM to test boot the iVentoy menu. We showed that the Windows 11 installation can run from iVentoy in VirtualBox because the Windows 11 install ISO does not have SPICE drivers, which is a requirement had we done that in an Incus virtual machine. So in general, iVentoy PXE network booting is useful for installing or testing bare metal machines on your network without having to carry around boot media. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.